Okay, so we're going to be going over the Unit 4 test review, which is all about triangles. Okay, so to start off with problem 1, it's having us find the missing angles in this diagram. Okay, so before I even go through and look at these, I'm just going to use the picture and kind of fill in the missing spaces. So first, when I look at angle A, okay, this is an exterior angle with the interior angle of 60. Interior and exterior always form a linear pair. So 180 minus 60 gives me that angle A should be 120. Next, I've got two angles that are 60. Angles in a triangle have to add up to be 180 degrees, so that means that this angle B is also going to be 60. B and C are vertical, which would make this one also 60. And then once again, angles in a triangle need to add up to 180. So 60 plus 50 gives me that this angle here should be 70. Okay? And then last, D and E are a linear pair, so 180 minus 70 gives you that E should be 110. So A is 120, B is 60, C is 60, D is 70, E is 110. Okay, next. It asks, could these lengths make a triangle? So based off of what we learned in this unit, if three numbers are going to make a triangle, the two smallest numbers have to add up to be more than the third number, or the largest number. So in number 3, our smallest numbers are 12 and 15. When I add those together, that is equal to 27. 27 is greater than 24, so yes. All right, for number 4, my two smallest measurements are 6 and 4. 6 plus 4 equals 10. 10 is greater than 9, so yes. For number 15, we've got 12 and 6. Okay, so 12 plus 6 is equal to 18. 18 is the same as 18, not greater than. So that's a no. And then for number 6, 18 plus 18 is equal to 36. That is greater than 34, so yes. Those will make a triangle. Okay. Number 7, if x is equal to 3, which angle is the biggest angle? So we need to start off by plugging in 3 for x, where we see it here. So 3 times 3 would mean that this side is 9. 2 times 3 plus 5 would give us that this side is 11, right? Double check that. Yeah. And then 4 times 3 minus 2 would give us that this side is 10. Okay, so our largest side is AC, that has a length of 11, which means that our biggest angle is going to be angle B. The largest angle is always across from the largest side. All right, number 8. We need to plug in 4 for x, so 3 times 4 minus 5 is equal to 7. Okay, 4 plus 4 gives us 8. 2 times 4 minus 2 gives us 6. Okay, so in this case, our smallest side is BC, which means that our smallest angle is going to be angle A. All right, number 9. What type of triangle is this? Okay, so one of the things that we learned is that if you have two congruent angles in a triangle, you're going to have two congruent sides. If you have three congruent angles, you're going to have three congruent sides. So that's how these angles are going to help us classify this triangle. But first, we need to solve for our missing one. So 65 plus 50 gives us 115. Okay. 180 minus 115 gives us that the other angle is 65. So, okay, we have two congruent angles. That means these two sides are also going to be congruent. So this is an isosceles triangle, and it's also acute, since all angles are acute. All right, number 10, we need to do the same process. So we need to add 50 and 60. That's 110. 180 minus 110 gives us that this angle is 70. Okay? Since all angles are different, this is going to be scalene. Okay? This is also acute, since all angles are acute. All right, number 11, draw three concave polygons. So a concave polygon is a polygon that's actually looks like it's caving into itself. So like there's an example of something that's concave. We could do something like this. Okay. Any of those that are, I don't know, sort of caving into themselves. Okay. Draw three convex polygons. So these are the opposite. These do not cave into themselves. Okay. All right, number 13. If a triangle has angles of 120 and 30, what type of triangle is it? So again, we're given these two angles. We need to solve for the third. So 120 plus 30 gives us 150. 180 minus 150 leaves us that our third angle is going to be 30 degrees. We have two congruent angles and an obtuse angle. So the two congruent angles means that this is isosceles, and the obtuse angle means that it's an isosceles obtuse triangle. All right, 13b. If a triangle has a 90-degree angle, does that have to be the biggest angle that triangle has, and why? So, okay, yes, this is true. If a triangle has a 90-degree angle, that has to be the biggest angle in that triangle. The reason why is essentially because angles in a triangle have to add up to 180. So if you try to have a triangle with a right angle and another right angle, you can't form a triangular shape. It basically makes some kind of quadrilateral, whether it be a square or trapezoid or whatever, but you can't form a triangular shape if you're going to have two right angles. Same problem with having an obtuse angle. If you've got a right angle and then the other one's obtuse, so like, how would I describe this? So like this, okay? So this is a side and this is another side. The only way you can make this a triangle is by adding a fourth side, and then it's no longer a triangle. So if angles are going to sum to 180 degrees, then like if you were to add another 90 to that, it becomes too much. Or if you were to add an obtuse, it becomes too much. Okay, so any So adding any other angle would be too much. Okay. You could also think of it like if they have to sum to 180, 90 plus 90 is already 180, so you couldn't have a third angle that adds to 180. So there's no way that it can make a triangle. Okay. All right, number 14. If all three sides of a triangle are congruent, then all three angles are congruent. And we want to write the inverse for this. Okay? So the inverse is where you make it say the not thing. Okay. So like this would say if all, oh, the marker's kind of dead. Okay, so the inverse would say if all three angles of a triangle are not congruent, then all three angles are not congruent. Okay. Yeah, that's got to be true. Okay. So if you think about it, if we had three angles that were all different, then that would have to mean that all three sides were different. It wouldn't be possible to have all three sides not congruent, but then three angles that were congruent, because the angles determine what sides are going to be congruent. So if angles are congruent, then sides are congruent. All right, 15, we're going to draw our different kinds of special segments, which will be on your test tomorrow. So you're not going to have to memorize these definitions. You are going to need to be able to recognize in a picture what these different special segments would look like, okay? So for example, draw the altitude. An altitude needs to go through the vertex and make a 90-degree angle with the base. So here's our altitude for that triangle. Okay. Perpendicular bisector. So a perpendicular bisector needs to be perpendicular, which means to make 90 degrees, and also pass through the midpoint of that segment. So here's our midpoint. I'm just eyeballing it, okay? So those are congruent, and our perpendicular bisector is going to go straight up so that it makes a right angle. Okay, so next we want the median. So a median goes through the midpoint and through the vertex. So once again, I have a midpoint that's here, but this time, instead of going straight up, it's got to go to the vertex. So there's our median. All right, and last one, draw the angle bisector. So an angle bisector goes through a vertex and cuts that vertex in half. So here's our angle, okay. Cutting that in half, there's our angle bisector. Okay, if these were isosceles triangles, could these all be the same thing? Yes. If you look at your notes and look at the pink line, in an isosceles triangle, the angle bisector, perpendicular bisector, median, and altitude are all the same line. And this is also what we wrote here. In isosceles and equilateral, angle bisector, perpendicular bisector, median, and altitude are all the same line. Okay. All right, so number 16 has to do with mid-segments. Okay, so if you take a look at your notes, at the very bottom, this is explaining all about mid-segments, what they are and what they do. So a mid-segment in a triangle is something that connects a midpoint to another midpoint. So it's always going to be connecting two sides and never two angles. Also, they're always parallel to the side that they don't intersect, and they're always half the length of the side they're parallel to. So for example, in this picture, here's our mid-segment, okay, which means that those two sides are congruent, and this is going to be parallel to that 20 inches side. Also, x is half that length, so if this is 20, divide by 2, so x is 10. Okay. Here we have another mid-segment. So these two are parallel. This one is 9. It's half the length of this one, so times by 2, and we get that x is 18. All right. List the angles of triangle ABC from smallest to largest. So in this, these problems, you really need to draw the picture. So we've got A, B, and C. You could do CBA or BAC, whatever you want to do, but once you've drawn your picture, make sure you label it correctly. So like AB has a length of 24, BC is 18, AC is 20, okay? So then, what was I saying? Oh, okay, smallest to largest. So smallest angle is always going to be across from the smallest side. So here's our smallest side. That means our smallest angle is A. Next smallest side is 20. So next we've got B. And our largest side is 24. So that means C goes last. Okay. We've got another triangle, ABC. I'm going to draw this one a little differently just so you can see that it doesn't affect your answer. So we'll call this CBA. Okay. Then AC is 5, CB is 12, BA is 13. Okay. Smallest side is 5, so smallest angle would be B. Okay. Next is 12, so that means next comes A, and then 13, so last comes C. All right. Triangle ABC is isosceles with base AC. AB equals 4x plus 15, BC equals 2x plus 55, and AC equals 3x plus 20. Find the perimeter of the triangle. Okay. So here we've got base of AC and a vertex of B. Okay. If this is the base, that means these two sides are our congruent sides. It says AB is 4x plus 15 and BC is 2x plus 55. It also tells us that AC is 3x plus 20. So for the algebra part of this problem, you're not actually going to need that 3x plus 20 because this base isn't congruent to anything. What we know is that these two sides are congruent, so we can set those equations equal to each other. Okay? So then if I've got 4x plus 15 equals 2x plus 55, subtract 2x. So we've got 2x plus 15 equals 55, subtracting 15. 2x is equal to 40. Okay. So we get x is equal to 20. Okay. All right. For the perimeter, we just need to take x and go plug it back in to where we see x in the equations. So this is where we're going to use that 3x plus 20. So 3 times 20 plus 20 gives us that this side length is 80. I'm just going to show you on my calculator here. 4 times 20 plus 15 gives us that this side is 95. 2 times 20 plus 55 gives us that side is 95. So the perimeter, 95 plus 80, that's 270. All right. Okay, next. It says that angle 2 is equal to 4x. Angle 5 is equal to 3x minus 10. And angle 4 is equal to 130. Okay? And we want to find the rest of these angles. Okay, so the first thing that you need to do, we know that interior angles sum to 180 degrees. Exterior angles sum to 360 degrees. So since our algebraic expressions are on the interior, even though we're given an exterior angle here, we want to find the interior so that we can set up an equation to solve for x. So we're going to start by subtracting from 180. 180 minus 130 gives you that angle 3 is 50. Okay? Blank piece of paper. All right, and now I can say that 3x minus 10 plus 4x plus 50 is equal to 180. Okay. All right, let's combine like terms. So 4 plus 3 gives us 7x. Negative 10 plus 50 gives us 40 is equal to 180. Okay. Minus 40 minus 40, 7x is equal to 140. Divide by 7. We get that x is 20. Okay, now notice our answer is not asking for what x is equal to. We have to use this information to go get these other angles. Let me just do it actually. Okay, so I don't have a whole lot of room to work, so I'm just going to show you on my calculator. All right, so plugging 20 in, 3 times 20 minus 10 gives us that this angle is 50. Okay, and 4 times 20 gives us that this angle is 80. All right, now I can use this information to go get these exterior angles. So like 6 and 5, those form a linear pair, so 180 minus 50 gives me that 6 is 130. Okay, 180 minus 80 gives me that 1 is 100. All right, so then angle 6, we've got 130, 1 is 100, 5 is 50, 7 is vertical with 1, so that would also be 100, 3 is 50, 8 is vertical with angle 2, so that would also be 80. Okay. Last couple of problems. So it says that D and E are midpoints of the triangle ABC. So that means that these two are congruent and those two are congruent. This also makes this line DE a midsegment. So that makes it parallel to AB and also half the length. So the first one says if DE is 9, then what's AB? So if DE is 9, that means AB is going to have to be double. 9 times 2 gives us 18. 22 says if this were 7, then what would this be? Divide it in half. So 7 divided by 2 gives us DE would be 3.5. All right, 23, if AD is 9, CE is 10, then what's DC and what's EB? So remember, these are midpoints, which means that these would be congruent. So 9 and 10. And last, here's our algebra one. So it says DE is 4x minus 7, and AB is 2x plus 4. What is the length of AB? All right, so the equation that we need to set up here, what we know is that 1/2 of AB is equal to DE. Okay. So in other words, what I can do is I can say 1/2 of 2x plus 4 is equal to 4x minus 7. Okay, 2 divided by 2 just becomes 1. 4 divided by 2 becomes 2. And now I can start solving algebraically. So I'm going to minus x, we get 2 is equal to 3x minus 7. Add 7. So 9 is equal to 3x. Divide by 3. So x is equal to 3. Okay, so if that's the case, then let's go plug x back into AB. So 2 times 3 plus 4 gives us that AB is 10. All right. Good luck on your test tomorrow. Make sure to study. I wish you the best.